All right, hey y'all, this is Miss Can, and I'm going to be showing you how to graph using intercepts today. So this is day one of graphing using intercepts. So the notes that I gave my kids today defined x-intercept, which I had already defined y-intercept in previous notes. But what the x and the y-intercept are the x-intercept, of course, is the x-coordinate of the point where the graph crosses the x-axis. So where does that line touch the x-axis? And likewise with our y-intercept, where does that line touch the y-axis? That's going to be very important to our lesson today, because our whole goal in order to graph using intercepts is to find the x-intercept, find the y-intercept, and plot both points. Now, we're going to be seeing two different forms today. The first one being standard form. I had already defined slope-intercept form to my students, so we're looking at standard form today, which when we have standard form, it looks kind of fancy. It's got ax plus by equals c, but a, b, and c are all just numbers. So the main thing that you need to know with standard form is when an equation is in standard form, x and y are on the same side, versus when we're in slope-intercept form, y is on a side, and particularly y is on the left side, all by its little lonesome. Okay, so in slope-intercept form, y is on the left by itself, x is on the right. But in standard form, x and y are on the same side. Now, in order to graph using intercepts, we have different steps based on if it's in slope-intercept form or if it's in standard form. If it's in slope-intercept form, you have your y-intercept already given to you, because whatever this constant is in your slope-intercept form equation, y'all, that is your y-intercept. So you have that given to you, and make sure if it's a negative, you bring that with you. The x-intercept, to find the x-intercept is that point where the line touches the y-axis, meaning that y value of that point is 0. So to find the x-intercept, we're going to let y be 0 and solve for x. Now, when it's in standard form, you have to find both the x and y-intercept. So, to find the y-intercept, I let x equal 0 and solve for y. But y'all, if I do that, that's going to be 0 times x. So that term just goes away. So we get to ignore that term and just simply divide out by this b to solve for my y. Okay? Likewise with my x-intercept. This will all make sense a little later once we start graphing. Now, with both of these, once I have my x and y intercepts, plot each point on your graph, on your coordinate plane, and connect them. Now, in our lesson, in our book, we have a second section that talks about interpreting the intercepts. And we'll see an example like this in a minute. But remember, with the x-intercept, that means you have an x value but no y value. So to interpret the x-intercept and tell what it means, then that means you have all of whatever the x variable is and 0 of whatever the y variable is. Likewise with the y-intercept. Please feel free to rewind back, look at these notes, pause, if you need to read back on any of those. But I'm going to move on to doing one of each type of example. So I'm going to graph one example that's in slope-intercept form, one example that's in standard form, and I'm going to do a word problem so that we can see how to interpret. Alright, so for number one is in slope-intercept form, because number one has y on the side all by itself. So, remembering that this constant that's in my equation is your y-intercept. So this is a positive 7, so my y-intercept is a positive 7. So I'm going to go ahead and put that in my y-intercept spot. And I wrote this out for my guys before they left, but I like to identify the x-intercept, identify the y-intercept, and actually write it out. Okay, now to do the x-intercept, we're going to have to do a little bit of work. So my rule was to let y equal 0 and solve this two-step equation to find x. So y equals 0, and we have put 0 in for y equals negative 2x plus 7. Alright, so this is a two-step equation. Remember, do not ever fool with what's attached to the x variable first. Always get rid of the constant. And the way we get rid of positive constants is with negative constants. So we're going to give this side a -7, and with an equation, if we give the right a -7, we have to give the left a -7. On this side, y'all, if we have nothing and we give it -7, then we have -7. Alright, these negatives and positives cancel each other out, leaving us with a -2x. Our final step to this two-step is to get rid of this times -2, so we divide by -2 on both sides. A negative and a negative make a positive, and if you type 7 divided by 2 into your calculator, you will get 3.5. So, my x-intercept is 3.5. Alright, so now I simply plot these points on the corresponding axis. So, from the x-intercept, I'm going to plot 3.5 on the x-axis. They have us counting by 2s. So this is 2, this is 4, 3 is directly in the middle, so 3.5 is going to be a little bit closer to 4. Alright, 4, 6, 8, so 7 is going to be in between 6 and 8. I have those points graphed, so I go ahead, and we have ID, so I always tell my students to take your ID and connect and draw your arrows. So, if you have it in slope-intercept form, remember, here's your B, here's your, whatever your B is, plus B, mx plus B, your constant is your y-intercept. Put 0 in, solve your two-step to get your x-intercept. Plot both points, connect. Now, when that's in standard form, okay, we have x and y on the same side. So, we have to do a little bit of algebra for both of these. So I'm going to come below my coordinate plane. Alright, and so for the x-intercept, and I'm just going to bring this down here so I know exactly what we're doing. For the x-intercept, you let y equal 0. But if y equals 0, this whole term gets to disappear. So I just ignore it. And I do 12x equals 15. Oh, I forgot my x. So 12x equals 15. And this is a simple one-step equation. Divide by 12 on each side. And 15 divided by 12 gives me 1.25. So, I'm just going to come up here to try to save a little bit of room and make it not look so messy. So x is 1.25. And I'm going to do the exact same thing for my y-intercept. Alright, if I'm going to get my y-intercept, I'll let my x be 0, so I cover up that term. And I have 9y equals 15. Divide both sides by 9. And 15 divided by 9 gives me, it's 1.6 repeating. So if it's a repeating decimal, I don't really like my students to write as a decimal. I prefer them to write it as a fraction. And we all should know that a 0.6 repeating is 2/3 of the fraction. Alright, so now I plot these they're nasty points, but I'm going to estimate anyway, so it's not a big deal. So on the x-intercept, I go ahead and go about 1 1/4 of the way, 1.25, and then I go 1 2/3 of the way. Alright, go ahead and take my ID, connect your points. Alright, so here, remember the constant was not given to us, our y was not given to us, but both were very easy to find. So if you're finding the x term, just ignore the y, divide out by the coefficient. If you're finding the y term, ignore the x. If you're finding the y-intercept, ignore that x term, divide out by the coefficient. And the last one that I'm going to do is number 4. Alright, so we're going to graph it, okay, first, and then we'll talk about what each piece means. So I'm going to highlight what I'm graphing, and so this technique will be exactly the same technique that I just did. Okay, so x-intercept, because it's in standard form, you ignore the y term. So I have 15x equals 1800. Okay, so 15x equals 1800, so I'm going to divide by my 15. 1800 divided by 15 gives me 120.